so it'll be the night before the exam or the morning of. So, all right, any questions about expectations or anything? I told you to slow down slightly. This is us slowing down. Which is sad, this is slowing down, but this is actually slowing down. Not fun. All right. So another thing I wanted to bring to your attention, in terms of studying and really preparing for 1-6, if you go to the notes, hopefully you notice this. There's this extra handout called Evaluating Limits Algebraically. I highly recommend basically just reading over this, thinking through it over and over until it really clicks. This is all of 1.5 and 1.6 in a nutshell, and like how we take all of our strategies and go through them as a flow chart. What do we do first? How do we tackle these other types of questions? How do we, if we're given this, how do we approach it? Okay? So this one's a little bit long, but it really goes through all possible cases and how to think about finding limits. And it has all the graphs at the end. So there are a lot of comments along the lines of, I get worried about finding limits when there's trig or e or natural log. That's where things like knowing this are relevant. If you have natural log of x, if you're finding the limits, all you really need is the basic graph. If you have this graph in mind, you're thinking through this when you plug in and find the limit. What are the relevant points here? What do I get if I plug in 1? 0. What happens when I go to 0 from the right? We follow this vertical asymptote. So the limit, as I go to 0 from the right of natural log, is negative infinity. What if I go off this way? It just goes up forever. This limit would be positive infinity. Those are like the only 3 facts you need to know about natural log. When we find limits, that's what's going to come up. All right. Same with e to the x would be this one. I need to know it has a horizontal asymptote, and I need to know it goes up forever on this side. Those are the 2 most important properties of this in terms of what we're actually doing in 1.5 and 1.6. Okay? So don't let all the trig or e natural log stuff, you need very little from it, but you can motivate it with the graph. If you have the graph, you really want to know what the limits are at this point. You can always think of those as, if I know the graph, I know the limit. All right? There's nothing to like plug in and show in some sense when you think of it that way. All right, so I definitely recommend spending a lot of time looking over this handout. Another thing that was a little bit concerning when I read the summaries. Let's look at the notes. There were a large number of summaries that only mention things about rational functions in this example. That is a very small part of 1.6. So, and I think it corresponds to what, video 1 only?
I ran out of space.
Okay. Yeah, I did put 150 character max. Although I had somebody write like 500 characters on something, and apparently it lets you go over. I think I tuned out somewhere around 100 characters.
Oh, it was 150 words.
It might be words. Yeah, who knows how it counts? I did that because I've learned in the past if you don't put a limit, people will write a 10-page essay.
I'll just remove all the spaces from
Yeah.
the words.
Yeah. Just put a capital letter, make it's hard to read. Maybe it's words. I don't know. Yeah, so I don't know, I do read those summaries, and it's always fun when some summaries have one aspect of the entire section, and like if I had to pick out what is the most important thing in the section, that wasn't it. So I do read those. I don't usually count them off all the time, but that was just something I've noticed glancing through. All right, make sure you're looking at these resources, especially this weekend. You really want to prep as much as possible for the exam. On Tuesday it says review day. That's a day to ask questions and all. Some of it will probably gear towards 1.6 questions, but anything in general. All right, how do we do the daily problem? Or not daily problem, prep assignment. Some people said this was too easy for them, so now they're concerned. That's what we've done to people in math. We ever give you a nice problem that's too hard.
If I wrote the problem wrong, but I solved the wrong problem correctly,
If it's equivalent, I usually only take off, sometimes I give full credit, sometimes it's like a half point or 1 point, just so you remember.
because I
Double check.
accidentally wrote x squared as the highest order exponent.
No, I might not care. I can't promise that. It's okay if you solve other problems correctly, as long as they're very much equivalent and test the one thing I had in mind.
I've provided enough work that I don't think it demonstrated mastery.
So this is, I can tell, I haven't graded these yet, but it's clear who really watched the videos or learned from that. If it's a polynomial and you want to find a limit at infinity, so if you want to find the end behaviors the way we say it in Math 190, you only care about the leading term. Which, this one was written in reverse order. What's the leading term? The 3x cubed, right? It's the one with the highest power. So if I want to find this whole limit, I only need to look at the highest power part. I can ignore everything else. Why is that true?
Because approaching really high values, that's going to have the most.
Yeah, think about x equal to 1 billion. 1 billion cubed compared to the number 5. Do I care if I add or subtract 5? Now this one's a little more misleading, but 1 billion cubed compared to 1 billion. Cubed, you're adding a lot more zeros, aren't you? You can actually ignore all the low order terms, you only need the high order one. In which case, you can do this either writing it this way or by graphing. I know the graph of 3x cubed, right? This is nice and you only need perfect graphs, you just need the right shape. 3x cubed looks like this, so what's the limit at negative infinity? Goes down forever, my answer is negative infinity. Or in this one, if I plug in negative infinity cubed is still negative infinity. The negative sign doesn't go away. So it would end up working out. Yeah.
Yeah, I guess I was wondering about that. Powering a infinity.
If you take infinity times infinity,
It doesn't really do anything.
it still represents infinity.
Does it do any sign switching with that, or just?
If you do negative infinity squared,
That'll.
that'll kill off the negative sign.
Okay.
And that's like basically saying, think about x squared. If I go to the right or the left, it still goes up. Whereas something cubed, one side's going to go the opposite direction as the other. Somebody did make a comment, it felt bad to divide by 0. You finally earned the privilege to divide by 0 in section 1.6. You've made it far enough in math, we let you divide by 0. And then hopefully you're doing it correctly because you've earned the right. The big one, when you divide by 0, there's a big thing in the book that uses 0 plus and 0 minus. Why do we need to specify whether it's positive or negative? 0 is not positive or negative, right? You can have positive numbers, you can have negative numbers, or you can have 0. 0 is not positive or negative. So why do we write 0 plus or 0 minus?
A number really close to 0. I don't know.
Yeah, it's close to 0. Close to 0 could be positive or negative, right? We want to make sure we have a positive sign or a negative sign when we do something like this. Are we squaring a negative sign or cubing a negative sign? Does the negative sign survive? And the way you look at that is knowing 0 plus 0 minus, treat it like a negative or a positive. Do we need to write 1 plus or 1 minus for the same technicalities? Is 1 plus positive or negative? Positive. What about 1 minus? Still positive? It's near the number 1, which is very much positive. So do we care about 1 plus or minus? That is not nearly the same issue as 0 plus or minus. That is the one where you have to be careful because it's this borderline case. Right? So that's why it's written this way in the book. I did post a second solution for those of you that wanted one that looks worse. You always got to be careful what you ask for. How can you always, this is a more rigorous way to do this, where you don't just say take the one term that matters, but instead you kill off the other terms. There's a trick that basically you want to multiply and divide by the biggest thing. So what do we think the biggest thing is? X cubed? So I want to divide by x cubed. Now can I just randomly divide by x cubed? That would change everything, right? So instead I divide by x cubed on the top and the bottom. Why would I do this? Now when you distribute this against this, have I changed the problem? This is really just a number 1, right? I'm not dividing by 0 because I'm going to negative infinity. So this is just a number 1 for any of these x values. But when I distribute it, what happens? Now everything gets divided by something big except this one. So then what would be the limit when I go to negative infinity? For this one, it just stays the same, right? And all the others, I'm dividing by infinity. What happens when you take the number 5 and divide by infinity?
You're dividing by another large number, you should get anything else closer to 0.
Yes. Think about, I always think of just 1 over x. One over x looks like this. What happens when I go out to infinity, either this direction or this direction? My limit would be 0. As I divide by something bigger and bigger, this levels off towards 0. So when I write 5 divided by negative infinity, okay, if I graph 5 over x instead of 1 over x, doesn't it basically look the exact same? So it would still level off towards 0. Okay. So the shortcut we learned in this section is this number, or this form, we can just say is equal to 0. Now, technically, we understand it as limits, and there's a lot of nuance there, and we probably shouldn't write exact equal signs because there's nuance, but we are going to let you break some rules here and actually do the shortcuts. If I see 5 divided by infinity, that is the number 0. Terminology is a little weird. We call it a non-indeterminate form. What's the difference between indeterminate and non-indeterminate? This was a little bit misused in some of the reflections. 0 over 0 is indeterminate. What does 0 over 0 mean? Do more work, you don't really know the answer? What about 5 divided by infinity? We just said that is 0. Do you have to do any more work there? Non-indeterminate means we actually know what this should be without doing anything else. So that's why we specify one versus the other. Right. What about 2 divided by infinity? 0? 3? Does it change? 1 over infinity we said needs to be 0. But on this one I was careful and I put 0 minus. Why did I put 0 minus? Yeah, if I'm going to negative infinity, I'm coming from beneath 0, right? Anytime you have just a 0 by itself, you need to know, is it positive or negative? Why did I not do this on the top? On the top, it's essentially 0, technically it'd be 0 minus, minus 0 plus, if I really cared. But then I add 3. What do you get if you do 0 plus 0 plus 3? Do I care about the zeros anymore? No, they go away. On the bottom, does this one go away? No, so I need to know, is this positive or negative? So in the end, I do all this, I get a non-indeterminate form, 3 divided by 0 minus. What does 3 divided by 0 mean? That means I have a vertical asymptote. I'm either going to get plus or minus infinity. How can you decide if it's plus or minus? You have to count negative signs, right? This says this is 3. This is a negative. So I know my answer must be infinity. This negative sign survives. I must get negative infinity. So this would be a solution using every technique that we talked about in 1.6 essentially. Well, I wanted to talk through this. On a problem like this, you don't have to do all this. On some of the other problems, it'll be more involved where you kind of need to. Hopefully I'll do one of those examples later. But I did want to talk through this. Does that make a little more sense based on what you saw? Or like why we're doing it? The hardest thing in math is knowing why you do something. Really what you learn in math is a bunch of tools, like using a conjugate. And then the problem is you learn so many tools you don't know when to use them. And like the worst thing is you're trying to solve a problem, you use the wrong tool, and you make it worse. The way you fix that is knowing what they do. Right? If you have a hammer, you know when you need a hammer. This is certain ways to solve problems. We need to know what is the context. Why would I need a plus or minus on this 0? Because I know the answer must be plus or minus infinity, and I need to decide, do I leave the plus sign or the minus sign? Once you have some motivation there, it's a lot easier to think through these without just memorizing everything. If you memorize everything, it's easy to teach yourself. All right. So I was going to write a bunch of these down, but I don't want to. 1 divided by infinity. We said is 0, right? 0 divided by infinity. Also 0, you can think of that as 1 times, or 0 times 1 over infinity. 1 over infinity is 0, 0 times 0 is 0. 0 divided by 3. We do so many things in here, we then mess this one up. Because they all start blurring together. Still 0, right? 0 to the infinity. Take the number 0 and just keep multiplying by itself. Should be 0. 0 to the first power. That just means the number 0, right? Some of these get confusing because 1 to the infinity. What is that one? Some people are going to be very confident and say 1. How can I explain this one? This is the one that easily messes people up. So, let's see. This would be the graph of b to the x for b bigger than 1, right? Yep. This is the graph for b to the x when 0 is less than b less than 1. This is the graph of 1 to the x power. Here's the subtlety. When we said 0 or 0, all these are in terms of limits, right? So when I write 1 to the infinity, it means 1 is a limit value. And infinity is a limit value. Why is that an important distinction? Is it always the number 1? If we think of it as a limit, it just means eventually we're close to 1. All right. If that's a limit value, am I bigger or less than 1? I should say barely, right? That's my big question. Is the number really just above 1 or just below 1? If it's a limit, it's one of those two probably, or it could bounce around next to it. But it's not always equal to 1. It can be above or it could be below. Why do I want to ask myself that question? What happens if I'm always bigger than 1? If this is like bounded above 1, it blows up. If it's bounded below 1, it goes to 0. So one case could go to a positive infinity, one case could go to 0. This one is in between. I can't distinguish where it could go. It could go anything from 0 to plus infinity or somewhere in between. So we call this one indeterminate. Basically, indeterminate means we don't know without doing more work. It might blow up, it might not, or it might go to 0, it might level off somewhere. I don't know unless I do more work. All of this is problem specific. So like one example of this, I won't bring up the full example. 1 plus h, when I let h go to 0. In limit, this would be the number 1, right? What about 1 over h? If I go to 0 from the right, that goes to plus infinity. So that's acting like 1 to the infinity. And yet, if I take this actual limit from the left and the right and compute, I get the number e. The number e is 2 point something. It's none of those. It doesn't blow up, doesn't go to 0. It actually goes somewhere in between. That's why I say it's indeterminate. Something else could happen. Indeterminate always means you have to do more effort. We'll look at these visuals next time, but you can see this. Anybody remember where this comes from? Yeah, it's a special rule in this section. Anybody ever do finance stuff where it was like quarterly compounding interest, daily compounding, and there was the continuously compounding? Your amount was your initial amount times e to the RT. Whereas if you do something like quarterly or other, it was some fraction here to the NT. Continuously compounding means you take a limit as the number n goes to infinity, and you just happen to get the e to the r out of it. Because that is this limit. That is why we have this special limit. It actually represents, or it comes from compounding continuously. Or that's why that formula works that we learn. It's because this limit exists and we know the value, which is a little different than anything you've ever heard for that when you learn the formula. So a bunch of these are somewhat non-intuitive. 0 over 0, we talked about infinity over infinity. We don't know. 0 times infinity. We've kind of had this one before. Something like 1 over x times x. That goes to 0. That could go, when that goes to infinity, it levels off to 1. Well, what if I put x squared here? Now the 0 wins, or sorry, the infinity would win. I put this cube, now it does something else, because now really the x on the bottom wins. We don't know which one wins in anything like this when we have these fractions. You have to do more work. That's what indeterminate means. Infinity minus infinity. We saw that for the daily problem. This would go to plus or minus infinity, this would go to plus infinity. Which one won? The one on the right. But context could change. If I put a negative sign here, a positive sign here, it would have been different. Or I could have made this power bigger, it would have been different. Right, so infinity minus infinity, we don't know. Infinity to the 0 power. That's a weird one. What's any number to the 0 power? 1. Why are these potentially not equal to 1? Because it's not that you always take your thing and raise it to the 0, you raise it to something near 0. And if you're near 0, something else could be happening. It's like all these formulas you ever learned, like 5 to the 0 power is 1, 8 to the 0 power is 1. That's because you're taking a fixed number, plugging it into exactly the 0 power. What these forms indicate is in limit it goes to infinity, which isn't a number, so what does it mean to take not a number and raise it to a power? And in limit this goes to 0, it's not always 0. So now you have to figure out, okay, there's a competition. If my base is infinity and I start multiplying, I expect it to get big. If my power goes to 0, I expect it to go to 1. Is there a certain one that dominates the other one or that breaks the tie? Right. That's where this term indeterminate is coming from. This is why this keeps showing up. And then all these, we know the answer is infinity. So definitely think through all these forms, really pay attention to this. We'll do examples starting Friday.